Okay, for problem number 5, it says this temporary bridge is set up kind of like in this diagram here. And we're trying to figure out the reactionary forces at A, B, C, and D. And it tells us the weight of the person here is 480 newtons, and they give us these various distances. Okay, so let's reconstruct this. This is going to be the first level here. And the forces on this, there would be a force upward at B. There's going to be a force upward at D. And there would be a force downward because of the reaction to the force of the weight, the support force. So this would be the force at D. This would be the force at B. And this would be, I'm just going to call it the weight. It's not really the weight because the weight's between the person and the earth. But there would be a support force on the person, which would be equal and opposite to the reactionary force on the board here. And actually, maybe I should go ahead and say that. This is really the normal force on the board from the person, which happens to be equal to the weight of the person, 480 newtons. Okay, so now I need to figure out both FB and FD. I could write an equation for this, and the equation would be FB plus FD equals 480 newtons. But that doesn't really help me a whole lot because I don't know either one of them, so two unknowns. So I'm going to have to use the torque idea, and I'm going to put the pivot point down near one of the ends. It really doesn't matter. I'm going to choose this end. Could have chose the other one. Actually, I could choose anywhere. That it's just easier at the ends to solve it. So this would be the torque from B would be equal to the torque from that normal. So we have the force of B times the distance all the way down, which is 12 meters, equals the 480 Newton force times the distance away, which is 3 meters. And so that means we could figure out FB, and FB is going to be 120 newtons, I believe. Yes, 120 newtons. Okay. Once I have that, then I can use this first equation up here again. So 120 newtons plus FD must be equal to 480 newtons. Therefore, FD must be equal to 360 newtons. Okay, so I have FB and FD. Okay, now I'm going to go ahead and consider the bottom case down here. So let me draw that case. So there's going to be a support force up at C. There's going to be a support force up at A. There's going to be a reactionary force to the B force. So yes, there is an upward force on B from the lower level. So that means there's going to be a force on the lower level from B that's the same magnitude. So FB is downward. And let me label all these. So this will be force of A. This will be the same magnitude as force of B, so I'll call it force of B. And this one here will be force, oops, I labeled these wrong, force of A. That one's force of A. And this one here is force of C, excuse me. Okay, so I can write an equation for this, and that equation would be that the force of A plus the force of C would be equal to the force of B, which we found that to be, force of B is 120 newtons. But two unknowns, can't solve it. So I need to consider the second condition, equilibrium, which deals with torque. So I'm going to pick a point where one of my two unknowns is either A or B or C. I think I'm going to put my axis down here. Doesn't really matter. I could put it anywhere along here. It just makes more sense to put it at A or at C. I'm going to choose A. Okay, so now writing a net torque equation. Let's see, I'll do it right here. So I know that torque from C is going to be equal to the torque from B. Torque of C is going to be the force of C times the distance away, and that distance away is 12 meters, equals the force of B, which we found already is 120 newtons, times the distance away, which would be 8 meters. And so I could figure out the force of C, which is going to be equal to 80 newtons. And once I know that force, then I can come up here and modify this equation. So it's going to be force of A plus this 80 newtons is equal to 120 newtons, which means the force of A is equal to 40 newtons.